All right, just a very quick video here to get the sort of the Arduino just acting as a power source basically, and to get a light, an LED to light up. So just some very, very basic stuff, not even doing any programming. So first thing I'm going to do is just plug in my Arduino. And so like I said, coming from the USB is 5 volts. Don't worry about the blinking lights at the moment. There's 5 volts coming out of that. And so that means I can power things. And that's how you can charge your phone and do other things. You've got some electricity, some current running through it. Not much, but what makes it nice is that it's very, very safe. You're not going to really hurt yourself with that. Now what we're going to do is simply, I'm going to sort of do two things. One is I'm going to look here and for my 5 volts. And one of the troubles I always have is trying to figure out which sort of one of these, which pin it goes in, and so I think it's the second one down. So I'm just going to plug in 5 volts, and to keep things nice actually, use red. Red is usually positive. I'll start off well here, putting in a positive charge. Okay, black is usually negative, and that's usually with our ground. So again, you can see there's 2. So this one, the VIN, voltage in, would be this guy. So I'm just going to go 1 up off that, and it's going to be my ground. There's 2 grounds there I could use, but there's my 2 grounds. Now what I'm going to do is just light up one LED, okay? And in fact, I could probably do it without even using the breadboard. So let me just see. Remember how I said before, the red, or sorry, well, this is positive. This LED has a positive end. So if I connect this to the positive, and don't try this at home, kids. No, it should be fine. There's not much current. And there you can see it lights up. Okay, so the LED is lighting up just with that current going through. If I do it the other way though, right, we talked about that the current has to go one way, has to go, this is the positive, so this is the positive end, right, the 5 volts. If I do it the opposite way, it ain't gonna work, right? So even though there's still current, or there's a potential for current to go through, right, there's a voltage across these, the diode won't let it flow, okay? It has to be from positive to negative. And like I said, even though this is green too, white, the LED itself is green there. Okay, if I grabbed another one, who knows, I just grabbed different colors. So again, which one is that? That one's looking like it, but yeah, so I think this one, I bent these, so a little harder to tell. There, that one's green too. Anyways, so those are going in there. Now in terms of putting it into a circuit and using the breadboard, just a little bit more work here. Now, usually I set it up one way. Unfortunately, with the simulator, it won't let me set it up, won't let you set it up this way that I like to do it. Makes it easier. But anyways, what I'm going to do is I'm going to plug in. So remembering this is my positive and this is my negative here. So what I'm going to do is just plug this in, and we'll just sort of set this up. Get that in. Get that in. I'm just going to keep those close. And you can do this in the simulator. Okay, I'm going to plug that in. I'm simply going to attach that positive. And so I'm putting it in the same row. Okay, so the same row as that positive leg on the LED. I plugged it in. And then what I'm going to do is I'm going to take this negative row, okay, or the negative cable. Now the negative is coming down here. Whoops, I touched it there. And then in here, right, and you can see it, okay, and it's very bright. I don't really want to hold it on too long there, but you can see that it's working. Now the big issue that we have is that brightness, and that's where this resistor comes in. So at the moment, you know, the LED has very little resistance, so with that 5 volts, there's a lot of current going through, and that's what's making it so bright. It sort of blinds you, one thing, and then the second thing is it can cause these to just basically burn out before they should. So what I'm going to do is just try to get this in here. Okay, what I'm going to do is plug it in, okay, and you see how I'm going right to the negative. I'm trying to get it in here. Sometimes it's a little, see, they'll want to bend, especially these resistors. They have very, very, very thin wires, so they're sometimes a little problematic, because basically there's like a little, like I said, there, okay, I think that's enough. And what I'm going to do is I'm going to plug this into the negative. And in the end, we're going to set up a bunch of these, kind of with this pattern, where we're going to have it come in, the current, the positive, go through the diode, okay, the LED, into this row here, row 3 in this one, and then across to the resistor, and then basically I'd like to sort of think of as collecting here in the negatives. And then that way we could just simply put a negative over here. Now what you'll notice right away, right, is with that, the brightness is a lot less. So you sort of get that understanding now that that resistor is reducing the current, and the less current that's running through, then the less sort of power, the amount sort of electricity can be converted into light, because there's sort of less electricity running through there, reduced current. This all comes into, if you've done it in science, V equals IR, okay, so voltage, right? Well, if we think about current, is the voltage divided by the resistance. So in this particular case, the voltage would be 5 volts, whatever the resistance is. Well, it had no resistance before, right? The current would be really high. Now the resistance is higher, so therefore the current is reduced. So V is staying the same. The R has increased, so you're dividing by a bigger number, so the current's reduced. Okay? Second thing there, P equals IV. So P, if you remember, is power, so basically watts, and so I times V. Again, V is constant here, the 5 volts, but because we've reduced the current, then the power is going to be less, and that's why that light bulb is less. It can convert, it has less power to convert. Okay, just to show you a couple little errors that might occur, okay, with your circuit, and you can do this one in the simulator, is put it in wrong. Okay, put it in the wrong way. Again, nothing happens. Okay, and that's just simply because the current's going in the wrong way. Okay, another common issue, I mean, if you don't have these lined up, so let me just pop it back in the right way. If you don't have them lined up, you're going to run into that same issue, right? Like the current's just not going to flow because so that's working. If I plugged it into, say, 2 here, well, it's not connecting with the positive, so current isn't going to be running. Obviously, same thing. If I took the resistor and I put it into the wrong one, so I plugged it into 4 there versus 3, again, there's no connection this way between 3 and 4, so therefore the current doesn't flow. The current kind of just sort of stops there. So, just plug it in there, and there we go. And so there we are. Okay, and then that positive, right, or is that negative? Again, obviously it has to plug into one of those grounds. If you plug it into the wrong one, okay, the current isn't flowing. It has to go into a ground. That ground ends up going back into the computer, okay? And obviously, too, the 5 volts has to be into the 5 volts. If it's not in the 5 volts, okay, it won't work. Now, it could be in the 3.3 volts, okay? Or there's another 5 volt there, too. So those can work, okay? But generally, it obviously couldn't be back in the ground. All right.